C'est ça.
Good afternoon.
Hello.
Hello, hello. And welcome to this presentation. We are going to talk about value types and pattern matching. And it's all about bringing your data back on stage. And we are going to see what it means, really. Thank you for coming. And welcome to Devox, for those of you who are lucky enough to discover this wonderful conference. My name is Jose.
My name is Remi.
And we are going to present this for you this afternoon. Before we start, just a few words of advertisement. Can we do that, Remi?
No.
Okay, so we're going to do it anyway. Talk about the dev.java website. We can do it, right?
Yes.
Can we? Unless you've been living in a cave for the past several weeks, you're probably aware that 21 has been released last week. Who doesn't know that Java 21 has been released? Okay, fine. So if you want to learn more about the Java 21, you can connect to this website called dev.java, which is a website delivered by the Java Platform Group at Oracle, with plenty of documentation and also contribution from prominent members of the community. These are the new pages that we published with the release of 21. You can also tune in on our mostly YouTube channel, I would say, but there's also the Inside Java RSS feed. You remember what RSS used to be, Remi? Like 15 years ago, we were using that.
You mean the Google Reader thing?
Yes, Google Reader. And there's also a podcast that is not only about videos. And if you want to learn more about Java 21, there is this series of YouTube videos that we did called the Road to 21 series that may be interesting to you. Right. The OpenJDK is the place where everything Java is happening. So here's the link that you can follow if you want to learn more about what we are going to talk to you about, especially the second part after the break will be about Valhalla. Now, Valhalla is not even in preview yet. It's still something in early access. So if you want to play with it, you need to download a specific JVM that you can find on this page, jdkjava.net, and here on the right, you have Valhalla, which is the JVM that we're going to play with to show you how Valhalla is working. And by the way, for those of you who are still working with the JDK 21, please be aware that you can also move to 22 right now. It's not completely feature complete yet, I suspect, but it's already available. All right, so my name is Jose, very quickly. When I'm bored, I like to push content on the web. And if you check my GitHub account, you'll find quite a lot of examples, if not all the examples that we're going to show you this afternoon.
And my name is Remi Forax, and so I work on different projects and on the specification, on some specifications, so the Lambda specifications, module specification, and recently on Amber and Valhalla. So we are talking about some weird name like Amber or Valhalla. What exactly it means? For small changes, those changes are directly done on the OpenJDK workspace named JDK. But for a big change, like the virtual threads change, they are first done in a separate workspace and then merge later. Those workspaces have code name, and this is the code name we currently have. So for data-oriented programming, what we will be talking about today, the code name is Amber. We will explain why soon. For trying to update Java to be better, to run better on modern CPUs, we have actually two different projects, Valhalla and Lilliput. Here we will talk only about Valhalla. Lilliput is about reducing the size of every object. We'll talk a little bit about it. For running Java in the cloud, we currently have 3 different projects. We have Leiden, which is a kind of the umbrella project. Basically, the idea is to be able to do some transformation after the code is compiled and before it will be delivered either as a Docker image or an hermetic Java application. So this is the umbrella. Until recently, there was not a lot of things in Leiden, but currently, if you are really interested, there is a prototype which is able to, when you JIT a code, every time you run your application again, the whole JITted code is lost. And with Leiden, you are able to reuse the JITted code from one run to the other, which is a nice feature. And so we have crack, which is a way to do a snapshot of the VM at some point and later restart at that specific point. And Galahad, Galahad is the name of the guy that found the Graal. So the Galahad project is to move some part of Graal VM directly inside the OpenJDK. So in the future, we will be able to use Graal as a JIT, like currently we can use C1 and C2. And for currently, if you are in Java and you want to call something in C, you have to use GNI, and this is about to stop.
That's not very good news.
Because we have Panama, and Panama is basically a way to directly call C code, because you can interact with the standard linker, I mean the C linker, and ask for a pointer and just call it. And we have the vector API, which is a way to access to SIMD operation. So in this talk, we will mostly talk about Ember and Valhalla. So what is Ember? Ember is a project with two goals. One is to have to be able to add very small changes to the language and the idea is to be faster than before. So adding a new feature should be it should take something like 1 year, 1 year and a half to add some small feature, like in Java 13, the text block was added, which is just multi-line strings. For this kind of small feature, we now have an OpenJDK project for them. Because in the past, it was harder to add this kind of small feature. It was always something like we will focus on Lambda or on modules, and all the small features had to wait at the bottom of the list. The other thing Ember is adding is pattern matching, basically. I don't know if you know this book or this series of books by Roger Zelazny.
I think you need to be in your 50 to know this series of books.
No, I know it. I'm still not in my 50. And in this book, if you want to travel in between words, you will use something called the pattern, which is why Amber is called Amber, if you want to know why. So let's start with Java is OOP.
Really?
Yes, at least at the beginning it was true. I mean, in 1995, Java was OOP, and 6 months after, or perhaps 1 year after, it was the opposite. OOP was Java. Exactly. And just let's recap what OOP means, at least according to Java. First, we have encapsulation, which is the idea that you have a public API, which is visible by everybody that want to use it, and you have a private implementation, and that's why you use classes to separate the public API and the private implementation. So in Java, if you want to use OOP, you will use encapsulation. And you will use interfaces and subtyping. The idea is, if inside your program, at one point of your program, you want to use 2 different representations, you will create an interface in between them. So this is the other part, which is basically the idea of interfaces. Technically, we don't need interfaces to be an OOP language. We need it if it's typed at compile time, because basically interface is just here for typing a union in between several classes. And then we need late binding, which is when you call toString on an interface or any abstract method on an interface. At runtime, you want to call the right methods. And so with these 3 concepts, encapsulation, interfaces, and late binding, we have been really successful. Or Java as a language have really been successful. Because if we have something like a web application, usually we don't write a whole application. You don't write your server. You just write some REST API. You don't write how to read or write JSON or things like this. You will use APIs. If you want to talk to a database, you will use API, and so on. So encapsulation, interface, and late binding make Java very successful. I mean, it's really a success story. But we want more. More. In OOP, basically, the focus is on the API. The API is more important than code. The code will change. We have a lot of libraries that have several versions. It's still working because people that are writing libraries don't do not a lot of stupid things. But Java is the OOP for Java is like if everything was a library. Even your application will act like a kind of library. And we want to introduce another concept. This is data-oriented programming. The idea is quite the opposite, which is for a lot of applications, data are more important than code. if you don't have the right modeling, or the right model for your data, you are basically toast. So in data-oriented programming, the idea is that data are more important than code. You see this in applications. Usually in application, you will do a V1, a V2, and so on, and they are not really compatible in between them. I mean, the UI may be compatible just for the users, but internally you will change the data model, usually. So what is important in data-oriented programming, at least for Java, is that we want to use the compiler, and we want the compiler to be able to help. The idea is if you change the data, the compiler should say, oh, you have changed your data here, so you need to change your business code here, here, and here. That's basically the idea. So this is how we implement object-oriented programming. In Java, you have an interface like populated with return a population, and you have several implementation, here a city and a department, that are implementing this interface. Each class is using encapsulation. We have an interface, and we are using late binding at runtime to call either the method population of city or the method population of department, depending on the class of the object at runtime. Encapsulation also means defensive copy, which is the definition of the encapsulation is the only way to change the state of an object is to use a method of that object, which means that we cannot use aliasing of pointers, because if we have a class that stores a pointer and the user code that's using that class is able to use the same pointer, we are in trouble, because it means that the outside code, the user code, can still change the pointer, and it will change the state of the class at the same time. So we are using things like defensive copy in constructor to duplicate the data and have separate pointers for this. In data-oriented programming, we're trying to model the data separately from the operation. The idea is that we only define the data. It's very important because it means that it's quite easy to see the data independently of what you can do on it. So here, if I want to create a city in a department, I will just say I have an empty interface. But having empty interface is a really great way to reuse code.
Because you don't put code in it.
Exactly. And so a city and a department are implementing that interface. And if I want to do a computation on the interface populated, instead of doing it inside each class, I will create a static method somewhere. I hope somewhere where people will be able to find it. And I will say, if it's a city, let's do this. And if it's a department, let's do that. And technically, in the code, there is something which is weird, which is the code is checking the population right in the middle of the computation of the population. Do we agree that it's a stupid idea? Yes. You don't do your check when you read something. You do your check when you write something. Because you are doing less write than read. Yes. Everybody agree? Yes? No more null check when you read something? Yes? But so this code is stupid, but we want to show that even if you have stupid code, we can do something.
You can be stupid, you mean?
So this kind of code is not great. I think everybody here knows that using if instance of is not a great idea. It's not a great idea because if you add a new subtype of populated, you will reach the assertion error at runtime. And here the compiler doesn't help. It's the opposite. Basically, we are saying, fuck you, compilers. So,
what about we make friend with the compiler again?
Yes.
What do you think?
Let's start a demo.
Okay, so I think I have a compiler somewhere.
I mean, yeah.
In the IDE. I told you this stuff is a mess sometimes. Presentation mode. Is it big enough? Yeah? If it's too small, there are plenty of rooms in the front, so please use it. All right, so I have this populated interface, and you said that there's too much code in it, so we're going to remove it. And I have this department object. I made the class final. Maybe I don't really need to make it final. Yeah, why not? And this class is a city. Maybe I can remove the final stuff. They both implement this populated interface. So they have this population method that will return the population of the city and the population of the department. And because you said that we shouldn't be using validation at read time, I wrote this validation at write time. That is, when the name is sent to me, I just check that the name is not there. This is how we should be doing it, right?
Yes.
Okay. Nobody does that, right?
Don't store null. Stop.
Nobody would do that. Yes? No, of course. Okay, and we have a wonderful business subject here, a business model that is just creating two cities and a department. Okay, and by the way, a department carries an array of cities there. We didn't do any kind of defensive copy, which is unfortunate, because if we pass this array to the class and someone keeps a reference to this array, and we can expect the code that is creating a department to actually keep a reference on this array, then modifying this array, the internal of this array, will modify actually the internal state of my department object. So maybe I should make a defensive copy here, right? Something like arrays dot copy of.
Yeah.
And then pass cities there.
So you can use clone, but for clone is slower than using arrays.copyof.
I never use clone. I like arrays.copyof.
Yeah, let's pretend there is no method on arrays.
Okay. And if there is an accessor, actually, because it's an array, if it was a list, I could have made list.copyof, and list.copyof returns an immutable, an unmodifiable version, implementation of list. So I would be storing an unmodifiable list within the state of this department, but here it's really an array. So if I return this array there, someone modifying this array would modify the internal state of my department object. And of course, this is not what I want to do, so I need to make a second defensive copy here. Is it better now?
I think you should use a list.
Should use a list?
Yeah.
Yes, but I like to call it in that way, you know, with this kind of vararg stuff. It could be a list. You want me to make it a list?
I mean, you can steal it have it as a varargs.
Let us do
In
that
the
later.
constructor.
Let us do that later. We'll do that later. Okay. So that's a list of populated objects. They all have a population, and what I'm doing is that I'm just summing them, and this is this nifty method here that is just streaming them, mapping them to their population, and summing them because I have a sum method on the int stream object, and this is really great. And I'm not going to bother running it because this is not what I want to do. All right, so data-oriented programming, if I understood well, consists in saying, I don't want to put any code in my interface. Am I right?
Yeah.
What's the price of adding methods in an interface? Because it's not just about removing code for the sake of removing code. I will have to put this code somewhere else. It's really about understanding what is the price of adding this kind of code in a populated interface. If I have another business requirement, Remi is interested in getting the populations of the city. But we have other friends, other business analysts, and another business analyst telling me, oh, we also need to have the surface, the land area, let me call it in that way, land area of each city or department. And then another one will tell me, oh, we also need to have the density of these populated elements, right? And every time you have a new business requirement, you will keep, well, if your reflex maybe to keep adding behavior on your objects and probably through the interfaces. This is what object-oriented programming is pushing us to do, basically.
And at the end, you have 30 methods.
Yes, or even 40, 50. Nobody ever saw this kind of legacy code where you have interfaces with tens of methods, if not more, with a super complex object with tens of more fields and methods, business methods. And then you need to instantiate them. Then there is a bunch of validation rules in them, so it's a mess to instantiate them. Sometimes you need to connection to the database to instantiate some of your business objects, which is just such a good idea. It makes the writing of unit tests close to impossible, which is great because you don't have to write them anymore, which is just a relief, of course. and this is what everybody does, right? Who's writing unit tests nowadays? Seriously. Nobody does that.
Yeah.
Oh, come on.
Make your code complex enough.
Yes, exactly. Exactly. And by the way, if you check, see, I just added two methods here, and if I check my business code there, I will have to recompile this stuff. Okay? Why? Because I just changed the interface. If you change the interface, then the compiler doesn't know that actually you're using only one method out of the three of this interface. Just so that the interface has been changed. So you need to recompile this code. What is the value in recompiling this code? Well, there's no value, because this code is just using one method and not the others. You're basically violating one of the principles of the solid principle, which is the I principle, called interface segregation. Okay, you're depending on an interface, but there is a bunch of content in this interface you do not depend on. And that's the price. Okay, if you depend on something, but you depend only on 10% of that thing, then you will recompile your code 90% of the time for nothing. And that's just the case here. So the approach in data-oriented programming is, okay, we're going to stop that. We are going to stop adding content here. Right? And I forgot to tell you something, which is when I added this land area and this density method, the nice thing is the compiler is helping me, telling me, hey, this city object needs to implement the two new methods you created in this interface. Okay? So when you update your business model, the compiler tells you, here, 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 and here in your code, in your application, there is code that you forgot to add, that you need to add because this interface is implemented by these different methods. And that's actually, even if you're violating the interface segregation principle, that's actually great to have this kind of, I would call safety net, okay, that protects you from writing code that is not correct at compile time. You could have a check only at runtime, but that would be a disaster. So fortunately, you have it at runtime, at the compile time. Okay, so data-oriented programming tells us, stop doing that. An interface is just here to characterize the nature of an object. These objects have a nature that is populated, but it doesn't tell us anything about the behavior of these objects. It's not about encoding behavior of your model objects. Okay, great. So now this code is not compiling anymore because on this populated object, unfortunately, I do not have this population method anymore. So I need to put this code somewhere. Okay. And because I don't have that many tools, actually, I'm going to say, okay, I'm going to create a public static method that is going to return an int. I'm going to call it population. Okay, and it's going to take a populated object. Populated. Okay, and I'm going to say return 0 because I just want this code to compile. And now I'm going to pass this populated object. Populated object to this method. Population. Populated. Of populated. And it's not the S, I don't want the S. Just like that. And by the way, that's a nice method reference. So let me replace it with this method reference. That's just a method that is describing that is giving me the population of a populated object. Okay, so the business code is roughly the same. It doesn't change much. The only thing that is simpler here is that because I don't have any behavior in this populated object, even if I update the behavior of my populated objects with the density, land area, this kind of thing, this business module now will not be needing any updates. I will never need to recompile this business module, which is better. But now I need to put some code here. Okay, and unfortunately, that's the code that you showed us, Remi. I need to check. I'm going to write it. Okay, instance of, yes, you. If it's a city, oh, what I'm going to do if it's a city? I first need to cast it. We all love casting, right? We all love instance of. Yes? Yes, all these people love instance of. So city is equal to cast city. Sorry, city.
Yeah, I really like this cast. Because if you take a look to the generated code, there is no cast. It's just a cast for the user.
So it's just
the VM is able to remove the cast. So it's already, you know it's a city you have done an instance of before. You don't need the cast. So it's just a ceremonial cast.
Oh, I love this kind of ceremony. So what's the second one? Department. Yes. Oh yes, department. I love this one. Okay, so department equal department. Gosh, this is so long. Return department population, and that's it. Return 0 here is not supposed to be called ever, so I'm going to throw, just as in a slide, a new assertion error. Yeah, just like that. We shouldn't reach that point. And I think that everybody agrees that this code is so much cleaner than the previous one. Fortunately, we are not using this ugly polymorphism anymore because we are doing data-oriented programming. And okay. Well, that's the end of this talk. Thank you for coming. We need to improve that, Remi. We need to do something. People are going to throw tomatoes at us if you don't. So the first thing that we can do, and actually this nifty IDE is okay to tell us that, is that we, instead of checking the type and then say, oh, I know that's the type, blah, 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 we can use a new feature, which is called a pattern variable. Okay? You see that here, I'm checking the instance of, and I pass this as a kind of argument to the instance of, which is called a pattern. So you may be thinking, oh, that's a nice syntactic sugar. At last, Java has that. Python had that for like 15 or 20 or 25 years or something, really, in the Stone Age. And now Java is catching up, which is great. It's actually much more than just a syntactic sugar. It's a new concept that is being added to the Java language called pattern matching. And we are going to talk much more about that in the next few minutes. And this is a concept. It's not a new concept. First, it has been designed back in the days of functional programming, like 50 years ago, 40 years ago, something like that.
Yeah, the beginning of the 90s.
Yeah.
The 80s, sorry.
The 80s.
Yes.
So that's, 40 years ago. And this new concept will probably be as important as the introduction of lambda expressions in Java 8. The revolution in the Java language will probably have the same order of magnitude when it will be done. So far, we have only portions of it. It's just one small bit at a time. Lambdas were different. There was Java 7, no lambda. Java 8, everything lambda. New collection framework, new stream framework, the stream API, lambdas all over the place. So it was some kind of big bang, some kind of revolution within the Java platform. Pattern matching is not that. We already have some bits of pattern matching. There is more to come, and we're going to talk about that. But in the end, the revolution will be in the same kind of order of magnitude. Yeah. So that's a pattern.
Yeah, I mean, I was part of the guys that designed the lambdas. For us, it takes almost 10 years. So it will be exactly the same.
Yeah, it started.
But now we can release part of the story without waiting 10 years.
Which is better?
I think it is. It's better to have feedback earlier.
Yes, absolutely. All right, so I kind of fixed the first problem of this code, which was this ugly instance of, and then the cast after that. Now we have this pattern and this city object that is created as part of the checking of the pattern. It's called the pattern variable. And by the way, I could also use this city object wherever it makes sense to use it. For instance, in that way, I could write this code. This code is compiling. I'm going to remove it. Okay.
But yeah, if you think a bit about it, it's a kind of weird, because this is the first time when you declare something before the curly braces, but you see it inside the next curly braces.
Yeah, and only within the curly brace. You cannot see it outside of the curly brace, of course. Absolutely. But there is something that is still missing in this way of writing thing, which is now I have this interface populated, which doesn't have doesn't carry any behavior. It's been implemented by these two classes, city and department. But if I had a third class, like a country class, for instance, well, the compiler is not there to help me. At runtime, I will throw this new assertion error with probably some kind of weird error message. But I will need to go back to the code, understand that actually I'm only managing handling two cases, the case of city and department, that I then need to add a new else if to handle the country case, which is really not great. The previous situation with an interface in which I add some behavior and the compiler tells me, hey, you need to implement this method here, 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 and there, was much better than this one. So this is still a work in progress. We need to go one step further. And this one step further imposes actually two features. So the first one is pattern matching. The second feature that we need is a new kind of switch, because this switch will be, the difference between the switch and the if-else is that the switch can check for exhaustiveness or not, where if-else cannot. So let me do that. I'm going to say, okay, and instead of doing that, I'm going to return, because now switch is also an expression, so I can return a switch. I'm going to switch on populated. And this switch can actually also work on patterns. So in the case I have a city, I'm going to return that.
Oh, you don't need to return.
I don't need to write the return because it's also already an expression. And in the case it's a department, okay, I'm going to return department.population.
If you take a look, it's a kind of nice, because all the verbose thing, you have removed it, and you have only the
and I need this stuff here
semantics
because it's an
part.
expression. But now the compiler is telling me this switch expression does not cover all possible input values. So if I want to do that at this point, either I write a default, and this new stuff, this assertion error is not there yet, which is not really great because at this point I only have a city and department implementation for this interface, but the compiler doesn't know that. So the compiler cannot help me in telling me, yes, you have covered all the cases or not. By the way, this default 0 could also be case object O and return 0. It could be the same. Okay, but this is not enough, and I certainly did not fix my first problem, which was if I add a new case, a new class in this hierarchy, I want the compiler to tell me, hey, you forgot to add to handle this new class. And this is why a second feature has been added in a JDK, and we have it as a final feature also, which is the sealed, this notion of sealed interface. What is a sealed interface, or a sealed type? The sealed interface is a type that knows all its implementation. So I need to tell the compiler, this sealed interface only permits, in that case, city and department. Okay, and it's not happy, because now, because it's a sealed, I'm telling, okay, I'm creating a hierarchy, and I want this hierarchy to be perfectly defined. And you see that this need to be closed, exactly. And you see that this class is not final, so it can be extended by something else that will inherit the populated type by transitivity. So I'm going to say, okay, you are final. And same for the department. Yes, actually, you are final. I could have also said this department is non-sealed. Okay, this would have worked also. But in a case we are showing you that is data-oriented programming, having non-sealed hierarchy of classes is not, well, does not work. That's not the idea. So this is final. Okay, and now in my business code, guess what? Oh, I would have liked a warning here saying, hey, you don't need that. I'm going to remove this, and now my switch is working. Ah, now I like that. Okay, what would happen if I add this country object, Java class, name, country? I'm going to say that your implements populated. Okay, so your final class. You see that he's not happy because country is not allowed in a C hierarchy. So I need to update this list of permitted classes. And now, if I check my business code, you see that the compiler can help me, telling me, hey, this switch expression does not cover all possible input values.
Yeah, but it's only half helping you because it suggests to insert a default, which is a stupid idea.
Well, that's the IDE.
Yes.
That's not the compiler.
Yes.
No, don't add any default branch. You don't want to do that, because if you add a default branch and you add types in your C hierarchy, then the default branch will catch everything. It's just like the throwing of the exception in your previous example. You don't want to do that. It will not help you if you do that. So now, country is there. I add this country object. Fine, and here I can just return 0. And now the compiler is happy. I'm going to remove this one and to stop to remove this country there. And you don't implement populated. I'm going to keep you for the moment being. Okay. Excuse me. So now I have this switch, which is much better. I have a code that is almost as clean as it could be. The compiler is there to help me in case something goes really wrong. And if I want to add some types in this hierarchy, then the compiler will tell me everywhere in my code where I need to update my switch statement without me having to look for them by hand, which is much better. Now we can go. So we have 3 elements so far in a language to support data-oriented programming. The first one is the CIL types. The second one is the switch on CIL types. And the third one is pattern matching. Okay? We are going to go one step further in pattern matching because basically here we are not really interested in this city pattern variable, I would say. The city pattern variable is only interesting in the way that we are accessing the population property of this city class. And this is why records have been added also to the Java language. I'm going to transform this class in a record, and that's going to be very fast. Okay, it's done. When you have an IDE that works well, it makes everything so much simpler. Okay, so I have a record built on 2 components. These are the components of my records, the name and the population. It still implements populated. It's fine for record to implement any kind of interface. Okay, and a record is a final class, so I do not need to say it's a final record. Okay, the CIL type is okay to be implemented by records without mentioning they are final, because actually they are also final. And we had some validation in the constructor of our class. I can show it again. Okay, we had this validation here telling us that the name should not be null. I'm going to convert it again. And it has been transferred in this special constructor. This is actually the constructor of the record. It's called the compact constructor. So you do not repeat the components of the record, and you just put some validation in it. We could have another validation, which would be if population is a negative number, for instance, we could throw a new illegal argument exception. Population is negative. Okay, so it's really very easy to add some validation in a record. And that being said, even if you serialize a record and deserialize it, this constructor will be called as part of the deserialization process, which is new actually in the Java language. When you deserialize a regular object from a class, regular class, the constructor is actually not called, meaning that if you have some validation rules in your constructor, they will not be enforced, which is some kind of problem when it comes to security. And I'm going to do the same thing with this department. I'm going to convert it to a record. Nice. This time the compiler took this constructor in that way. It didn't have to do that, actually, because I can remove this guy, say, okay, I require an object that is not null, but I can modify not the internal state of this record, but this stuff, which is the argument received by the constructor, and make my defensive copy at this level. For cities, I still need to have this defensive copy here, which is fine. And now that I have records, because the compiler knows that a record is built on components, it can deconstruct them using a pattern matching for record. And this is what I'm going to do here. Instead of saying that this is a city object, I'm going to say, oh, this is a city object that is built on a name and a population, population being an int population. And the same for my department. So I don't need this pattern variable anymore. I'm creating two pattern variables, a name and a population, and here I'm just going to return the population because this is fine, and same for the department. Okay. Yeah, he's not happy because this is not the population. Oh, can I deconstruct it in that way? I don't think so. I explicitly need to say that it's an array, right? How is this guy made? It doesn't have a population.
No, it will be 0, but you can still match.
Never mind.
I mean, you can still ask for a deconstruction with the two component.
You want to do that? Okay.
Yes.
So I'm going to copy this. Yeah, I'm going to copy this. rename cities. And then I will need to do something here. Let me put 0 for the moment. Okay. By the way, this population here is not the right one. I'm going to remove you. Bye bye. Okay. So what do I need to do here? Probably something like that. Sorry. I need a return here. Do I need this return? No, I don't, no. Because I'm just going to do arrays.stream on the city. And then map to int business code population. Okay, and sum. And this is what I want to return. So I don't need this. Yeah, something like that.
Perhaps you should show, if you have curly braces, what you should do.
If I have curly braces, if I add curly braces, I need to add a return.
No, it's not a return.
Yes, I know. Okay. Here I need to explain that this value should be returned. But if I do return, I will have a compiler error. And this compiler error comes from the fact that there is actually an ambiguity in writing return here. Will it be a return from within the switch expression or from within the method? And Java doesn't like being ambiguous. So it's not a return. It's a yield. This is what you want to show. Yeah. Yeah. So if you need to do this kind of thing, yield is the keyword you want to use.
So yield, with yield, you are able to stop the switch and not stop the whole method.
Exactly. Here we are exiting the switch and not the method. There is no more ambiguity. All right. So this pattern is also a pattern. It's a different kind of patterns. The previous pattern was the pattern on types. It was allowing you to identify the type and create a pattern variable on the type. Now it's identifying a record. For the moment, it's only working with records. In the future, it will probably, well, it will work with regular classes, and we're going to see that. But now it's working for record, and it's a final feature of the JDK 21. So you can use it if you're fortunate enough to already run your application using Java 21. Nobody is using Java 8 anymore, right? Not so sure. But you see that you can go one step further with that, because among the components of this record, you have a record that is not used here, the name there. And every time you need to fix the value of the pattern variable, the accessor of the corresponding component of the record is actually called. So here, to get the value there, this city method here is called. So there is the copying of the array that is called. It's not a backdoor to access the internal state of the record. Okay. By the way, if I change the, and this is a really nice thing, if I change the the model of my record, for instance, I say, oh, but this city is actually part of a department, so I'm going to add this department there. I have updated my model. Because the compiler knows so much, you see that this record pattern is not compiling anymore. So actually you have a finer control on what is compiling in your application than the one you had when you were using methods in interfaces. If you're changing the model of your objects, the switch on records that you've spread all over the place in your application are going to stop compiling so that you can check exactly what is going on, and if you need to update this code to, well, use this new model, or if it's okay to keep it in that way. All right. So changing the model of your object model will actually create compiler errors, and this is what you want. This is what you need to handle your application properly. All right. So we don't need this name. And as a preview feature in the JDK 21, and I will see if we have activated the preview feature in this IDE, because I didn't check beforehand. Yes, we did. So that's a preview feature. You can say, okay, This variable is actually an underscore. This is another kind of pattern called the unnamed pattern. And in that case, the compiler will not call the accessor of the name component of the record, and the name will not be made available in the rest of the code.
Technically, what you have written is not a unnamed pattern. It's the unnamed variable.
Yeah, you're right. So you see, for instance, I try to call, because it's a string, right? So if I try to write it in that way and call toString on it, it's not going to work. By the way, it's going to give me the real garbage because it's not a variable. I can't use it as such. Okay. You can go one step further, saying that, oh, but this is a var. Actually, it's also working, and I could also put a var there. Using a var is a little different. It kind of breaks the idea that you want your business code to break in case you have a change in your object model. Because now if I say, oh, but this string name is not a string anymore, it's a, I don't know, it's a string builder, for instance. That would be really stupid, but that's just an example. You see that this code is still compiling because of the var keyword that have been used, and which infers the real type at compile time. So is it a good idea to use var? That's really up to you to decide. Personally, I'm not so sure. I would prefer to have something that is not compiling and that lets me decide if I should upgrade this code or not. And by the way, the unnamed pattern is this one. So I could also say only with this underscore character, okay, I'm not going to take into account the first component of this record, whatever this first component is. And once again, if I change the model of this first component, sorry, means that, yeah, it will not make any change or any compiler error in the business code. Is this what I want? I'm not so sure. So I would prefer to keep this string underscore. There are other places where you're using pattern matching, but not in the data-oriented programming context, where using this underscore, this unnamed pattern would make total sense. All right. Yeah?
Yeah.
And I think that's it. Oh, we didn't show the when and stuff?
Yeah.
Okay.
And what if populated is null?
What if populated is null? Well, I can now have a case null to throw, I don't know, a new null pointer exception, for instance. What? Does it work?
Yeah.
Maybe it's not that great. You can have a case null, and you can also have this kind of things. For instance, here I don't want to handle the case that the cities array is empty. So I could say, okay, when cities.length is greater than 0, okay. Now the compiler will tell me, hey, your switch doesn't cover all the cases anymore because it was able to detect that, yeah, this stuff is a restriction on a pattern, so I need to duplicate this guy and tell him, okay, now I know that this is when the length is equal to 0, so I can safely return 0 because this department doesn't have any population. Okay, and that's what covers the data-oriented programming approach so far. So it relies on several elements: CIL types, records because you want to deconstruct your object model, switch expression, which is exhaustive and which will allow you to do this if instance of in a much cleaner way, and record patterns to be able to deconstruct these records. So CIL types, records, and pattern matching to switch.
Yeah, it still works on enums too.
No, absolutely. Okay, I think we can go back to the slides.
So yeah, as Jose said, the idea is not to use data-oriented programming everywhere. It's to use it on data. I mean, if you have a class like string, you will not use a record for it. But for everything which is your application data, we believe that it's easier and better to use data-oriented programming, which is defining your data independently of all the business method you can implement on it. It's a nice way to decouple things. And as we have seen, the compiler helps to if you change the data, because basically the idea is that the data are the source of truth. And so if you change the data, the compiler will pinpoint where you should change your code, or at least where you should take a look if you need to change it or just change the definition. So it's based on record pattern. It's based on seal types that make the switch exhaustive. And the nice idea of the record pattern is that you can detect not only new subtypes, but structural change, like a new record component. As we said earlier, it's not a new thing. It has been studied.
Is there a new thing in Java, by the way?
No. Java only steals things, never invent things. So there is a guy named Philip Wadler, which tried to characterize. So it's at I think at the end of the 90s, trying to characterize language depending on the fact that they were using polymorphism or pattern matching. And it's what he called the expression problem. If you use polymorphism, you can add new subtypes, but you cannot add new operation. If you add a new method in the interface, you have to change all the implementation. And for pattern matching, it's the opposite. It's easy to add a new operation. You do a new switch in your static methods, and it just works. But you cannot add new subtypes, because if you add a new subtypes, you have to change all your switches.
That's under the assumption that you're not the owner of the code.
Yes. Obviously, if you have the owner of the code, you can
get
change
an object model,
both.
But you cannot touch it.
Yes. So it means that now in Java we can choose which one we want to use, which is basically, if you are in the libraries, you will prefer to use the polymorphism things, because it means that user of your libraries can add subtypes. But if you are in an application, it's basically the opposite. You will want to add new operation instead of changing the data, or at least if you change the data, you know that you will have to do a lot of subsequent changes. So sadly, we cannot have both at the same times. Several research languages tried to get both, but currently there is no solution for that. So more patterns. We want to introduce more patterns.
So that's the crystal ball part of the...
Yeah. In the future, as for now, in the future, we want to introduce more pattern. We want to be able to do to have a record pattern on classes. not only on record. So by example, if you have a class point, we want to introduce a new syntax to say, hey, if you want to match a point with a record pattern, you need to write a special method called currently, it's a provisional syntax, a matcher, a method matcher. And what a method matcher is basically kind of the opposite of a constructor. That's why we call it deconstructor. The idea is from an object that exists, you want to get all the components of this object. So here, my matcher will match point, obviously, and extract both x and y. Because this is code, we can change it and just say that it match 2 and 3 if you want. You can write the whole thing as you want. So the idea is to be able to do record pattern on classes. Another idea is to have named pattern, which is basically the equivalent of a static factory in reverse. So we want to be able to do a switch on optional, by example. You have two ways of create an optional. The first one is to use off, the other is to use .empty. And we want to do exactly the opposite, which is match with a case optional.off, or match with a case which is optional.empty. This will call these two matcher. So the matcher named off is called when you do a case optional.off, and it will return a t, and for the matcher empty, it will return nothing.
Will the switch be able to check for exhaustiveness in that case?
Yeah, that's basically the idea. The idea is that if you have several matcher, or at least currently, that's the idea. If you have several matcher, you have to have a case for each matcher. Maybe we will have to introduce another syntax to say those matcher are exhaustive and those are not, or things like this. But again, if you have an idea of how to specify in terms of syntax this kind of stuff, please write a blog.
Or come to the mailing list.
Yes, but yeah, writing a blog is better than just writing an email. It's more construct and...
You can do both, write the blog and advertise it on the mailing list.
And the other thing we want to be able to is to use deconstruction, but not inside a switch, but when you do assignment. Assignment, yeah.
Assignment, yes.
Yeah. So if you have a point P, to be able to deconstruct it as an X and a Y. Currently, we are using let. Perhaps there is a better syntax. And by example, if you want to loop over the key and the value of map.onTreeSet, there is no map.onTreeSet in the slide, but let's say there is a map.onTreeSet. So you can get automatically the key and the value. It's exactly the same kind of
Do you mean that the previous preview feature that was the enhanced syntax for 4 has been dropped off?
Yes. So yeah, if you take a close look, we try to implement the 4 things, but the semantics was not quite right. So in 21, there is no syntax for the 4 feature, but soon we will get one.
Another reason for you to try preview features and get feedback, because this is what happened with this 4.
Yes.
It was not quite right. It was detected when it was still in preview. Guess what? Just great.
Yeah, yeah. We had some spurious null pointer that we haven't thought about it. Oops. So this is the current plan, and what is released is in green. What is in preview is in orange, and what should be delivered soon, whatever soon exactly means. So seal type and instance of, instance of with a pattern were already final in, I think in 17 we had.
Seal types and
well, at
I
least
think so.
before 20.
Seal type was before.
Yes, perhaps instance of
switch.
What was after in perhaps in 19.
But nobody's using 17 anymore. Everybody moved to 21 already.
Yes, just today.
Yeah, you see, nobody's complaining. So yeah.
Exactly. And so in 21, record pattern and the type pattern for the switch were released as final. Currently, the unnamed pattern is in preview, but we are thinking that it will be only one round of preview, so it should be in final in 22.
Which is next March?
Yes.
So that's basically tomorrow.
Almost. And for the let things, it will soon come after. And for the matcher, I think we have a good idea of how to implement it in the VM. We have a less good idea of what will be the exact syntax of it and what will be the exact semantics of it, especially around the exhaustiveness of all the matchers. Okay. Time for a coffee break.
Do you feel like a coffee break? Yes? I think these people need a coffee break.
Let's.
So what about we start again in 20 minutes?
Yeah.
That will make it 2:05 p.m. Have a nice coffee and see you after that. Welcome, welcome back. We are going to talk about, I hope the coffee was good. I hope it was warm. Did you have coffee, Remi?
No.
I didn't have coffee neither, so okay. If we fall asleep during the second part,
just shout.
Just shout and we'll try to wake. So we're going to talk about Valhalla. Valhalla is probably among the oldest projects in the OpenJDK as of now.
Yeah, it starts 9 years
9 years ago, something like that. And I remember seeing James Gosling on stage at JavaOne several years ago, telling the people, oh, Valhalla, that's an easy project. Just take 15 PhDs working on it and you should have a solution. And then what you will have to do is to implement them. Okay. So we're going to talk about that because Valhalla is quite close to delivering at least value types. Actually, value types could come in quite a near future, which is an excellent, which would be an excellent news if it's the case. Yeah.
Yeah.
Okay.
As a preview soon.
As a preview. That's a possibility. It's not done, but it's a possibility. The starting point of Valhalla is this book. Now, maybe some of you don't know this book. Well, if you don't know it, you probably should not shout that too loud. And if you do know it and you don't know the content, maybe you should try to read it.
No, you only
at least the introduction.
Yes, only the introduction.
Yeah.
I mean,
and the table of content, so that you can answer questions during coding interviews, because usually these are the parts that people are asking questions about. Usually they don't understand the rest, the guys who are asking the questions during these interviews. So unless you know it very well and you can explain the person who is interviewing you, You should just read the introduction of the agenda. It's the book of the fundamental design patterns of object-oriented programming. And we just explained you that object-oriented programming was not the only paradigm that you can now use in Java. You can use OOP. You can also use functional programming, kind of, with the Lambda expression, the stream API and stuff. This is very functional. And with Valhalla, we will merge all this with data-oriented programming to bring many performances, new performances to the computation you're using on your JVM. Page 20 of the introduction, you can read this. Favor object composition over class inheritance. A principle that is not actually used in all the design patterns of the rest of the book. There's like a dozen of them that favor inheritance over composition, which is fine. This book was written before Java, actually, and probably at the time it was written, they were lacking many tools to actually, I wouldn't say implement, but enforce this principle. But nowadays we have many tools to enforce this principle. So the question is, why does nobody follow this principle? Okay, so for instance, if I take a look at this kind of code, I have an array called populations, but this is an array of ints. And if I want to sum all these populations, I'm going to write this for loop, which is old Java 1.5, by the way, because there is a for each statement. Yes, you're right. So that's Java 5, 2004, 20 years old. It could be older. And if you want to use a stream because you like Java 8, that's still the code that is 10 years old, almost. Not exactly, but close to 10 years old. But you're still dealing with ints, and you rely, the readability of your code basically relies on the choice you made for your variable names and the comments you can add to your code. Now, we all know that comments is super fragile, so don't rely on that. Variable names is probably better, but it's also kind of fragile. If you were to follow this principle, favor object composition, you could wrap this int in a record, call it population, and then what you have in your end is a population object, right? Writing meaningful variable names is nice, but writing meaningful type names, that's even better. Okay, especially with data-oriented programming that we showed you before the break. And you could just add them in a for loop, or you could use a stream and a reduce method and create an add method on your population record to add to population objects, instances, and return a new population object with the sum. Why aren't you doing that? Why aren't we doing that? Well, for one very wrong reason, which is called performances. Because if you try to add this kind of code in your application, you will have an old bearded man or woman, well, not bearded woman, I hope. Sorry about that. That was really a very bad joke. Telling you, pointer chasing, my friend, you are going to pay the price of accessing an int through a pointer, and this is pointer chasing, and pointer chasing, it's not handled very well by the modern CPUs. It's a disaster, it's a performance hit, and you will have crappy performances. Now, what you call crappy performances is really performances that are probably 500 nanoseconds slower than the addition of an array of ints. Okay, we are talking nanoseconds. If you're running in some kind of Spring Boot application, people are going to access your data in the order of the milliseconds. Okay, nanoseconds, milliseconds. So optimizing your code for nanoseconds when you're running in milliseconds, I'm not sure that's the best idea. Especially, I'm not sure that sacrificing readability for this kind of performance is the best idea you can have. If you create an histogram, for instance, this is the histogram of population by city. This is what the comment is telling you, because if you're watching the code, it's really a map of string and integer. So you deduce that string is probably the name of the city, and that integer is the amount of people living in that city. Great. Wouldn't it be much clearer to have two records, city and population, and have a map of city and population? Okay. So we are sacrificing the readability of the code we write for the sake of performances. And that's, I don't know if it's a good idea or a bad idea, but that's precisely the point that Valhalla aims to fix. Modify the way your code is executed by the Java virtual machine so that you do not need to choose between readable code and performances. The idea is to make your abstraction almost free. And sorry, and up to 7 to 8 years ago, the Valhalla people were talking about coding like a class, working like an int. Okay? Now, that was the original goal. I wouldn't say it has been dropped off, but maybe a little different than that. But that's still some kind of idea behind all this work. And basically, the performances of all these patterns, an array of int and an array of population records that you're summing, should be the same. And that's the goal of Valhalla, and this is what we are going to show you in the rest of this presentation. Your go.
Yeah. So these goals can be decomposed into two different things. Because from the CPU point of view, or for a VM point of view, data on stack and data on heap behave not the same way. So what abstraction for free means that if you use this kind of new class on stack, you should have no allocation, which means that you are using a class, but in terms of performance, you have exactly the same performance as a primitive type. On heap, the idea is slightly different. What we want is to have no header. In Java, every classes has a header, but we want this kind of classes to have no header and no pointers too, which means basically that this kind of classes will be embedded inside a bigger class.
But I thought there was no pointer in Java.
There is no pointer, but there is a null pointer exception.
Yeah. Oh, you're right.
Yeah, pointer or reference. So what abstraction for free on stack means? It means that objects like optional or what I call true builders, which is a builder that every time you call a method on it, return a new instance. So if you do logger.warning.onConsole things, logger.warning will create a new logger, and onConsole will just do the printing. These intermediate objects, the one returned by warning, should not be an allocation. So wrapper values like all the Java-long wrappers like integer, the big double or big float, or things like complex, month, all the java.time classes, like local date time and so on, should be free. There should be no allocation for it. And on heap, if if we have, by example, an array, we want, instead of having an array of pointer, to just have an array of value. This is a drawing of an array of 4 integers, and you can see that all the headers are bigger than the data part.
Are you telling me that to transport a 32 bits integer, you actually need almost 256 bits?
Yeah, you need a lot. Let's call it that way.
Doesn't look very efficient.
Yes. Yeah. So at the beginning we talk about Lilliput. The Lilliput project is to try to reduce the size of the header to 64 bits. And if the gods are with us, 32 bits. But currently there is a prototype with that works with 64 bits. But anyway, here what we want is when you store something on heap to have no pointers and to only store the data. So the high-level goal is to realign Java with the current hardware. Just remember that at the beginning of the 90s, doing a plus or doing a star like in C, trying to follow a pointer was mostly the same cost. That's not true anymore. We have cache misses, and we have cache misses of cache misses, and so on, because we have several levels of caches. Valhalla starts as an open JDK project in August 2014, led by Brian Goetz, which is the guy responsible of the language, and John Rose, which is the guy responsible of the VM. Yeah, John Rose is quite old. That's why the project is named Valhalla, because it will be his last project. Yeah, if you are a leader of an OpenJDK project, you can name it as you want. So we have done several iterations. I mean, a lot of iteration currently. So we have a kind of a minimal product named MVT and LW1, 2, 3, 4, and currently we are trying to implement LW5. That should be the one in preview soon. LW5 is still in construction. So currently, if you download the Valhalla build, what you have is LW4. So what we will show, and all the performance are based on LW4, not LW5. Technically, LW5 is not a rewrite in terms of performance of LW4. It's more, we want exactly the same performance, but we have changed the binary representation inside the bytecode. So currently, what we will show you is LW4, but using a bytecode rewriter. We are using a bytecode rewriter mostly because there is no IDE that supports the current syntax. So what the bytecode rewriter do is you put annotation and it will rewrite the bytecode as the compiler of LW5 does. Let's go to our example. We want to sum the population of a city. We have a record city. We have an array of cities, and we just do a for loop on the population of the city. If we take a look to the data in memory, because we have an array of cities, we have an array of pointer of city object that contains a string and an int. If we want to compare the primitive version with the object version, in one case we will declare the population as a small int inside city, and for the other case we create a record population, and in that case the population of the city is the population object. And then when we loop over the population, we will create a new population with the value 0, and we have a method add that just adds the population to the current population. If we take a look to the layout in memory, oh, it's swapped. So with the object version, the city has an object population in it, and with the primitive version, there is an int in it. If we take a look on stack, what's the main difference? The main difference is that you can see those red new, which is asking for creating a new object. So we create a new population object with 0, and for each value we recreate a new population object. Here I have inlined the population.add, so we can exactly see the allocation. So basically, if we try to compare primitive and object, we have two different effects. On stack, we have extra instructions that are asking to do allocation, and in memory, on heap, we have extra indirection. We already have techniques to try to solve this issue. We have something called the escape analysis for on stack. I don't know if you know, but if you write new in your program, it doesn't mean that the VM will do a new. If the VM is able to see the allocation and the last time an object is used, the VM will try to remove the allocation and put all the fields of the object directly in registers. And for the memory layout, it's more complex because sometimes indirection is good. If you move data on heap, moving pointer is far efficient than moving real, I mean all the data. So we have trade-off here. So now I will try to describe the current state of mind. We introduce a new kind of class named value class. What a value class does is to give up its identity. By identity, I mean address in memory. So we want to create a new kind of class. It's still a class. And this class is saying to the VM, I have no address in memory. It still inherits from Javalog object, so it's a real object. You can implement interfaces, you can define methods, fields, nested class, and so on. All the objects of this value class are reference. They are instances of classes, and they can be assigned to null. So how to declare a value class? We have a nice keyword, value, that you can put in front of a class. You can create value record if you want by putting value in front of a record if you want. What you are asking here is to do scalarization, which is on stack and only on stack to replace an instance by the value of all the fields of the object. So what the value class does is just solving the stack issue, avoiding to do dynamic allocation when you use this kind of class on stack. So basically, as a programmer, you will write this kind of code, and for the VM, it will mean this kind of code, which is you write a new, but technically, if you take a look to the assembly code generated by the VM, it will just create a register with the value. And this is something important, which is we are not solving the value classes at compile time. At compile time, a value class is still a class. You have a .class file, and what is done is the optimization are only done at runtime. It's not the compiler will not change. The compiler will be fast as usual. We are not in Scala. Oops.
What do you mean?
So there is no rewrite by the Java compiler. The optimization are only done at runtime by the jet. We have several problems with this kind of things. The first one is if you pass this kind of object, an instance of a value class, as parameter of a method, for the VM you are sending usually the address of the object. But because value class have no address, we need to do something. So we want to pass all the fields as values directly, but it means that you cannot be able to modify the field of a value class. So a value class is not a struct, if you prefer. Because with a struct, you know if you pass the object by value or by reference. In Java, you pass everything by value, which means that all the fields have to be final. Technically, it's not enough. Why? Because even if you have all your fields final, your object is not immutable. Do you agree with this? Yes?
If all the fields are final, the object is not immutable.
No, there is a place where the object is mutable, which is inside the constructor. Inside the constructor, your object can be mutated. But after the constructor,
nobody
you're
knows,
fine.
because nobody can see an object while it's being constructed.
yeah, maybe. So we need a spatial mechanism inside the constructor to say, inside the constructor, it's okay to mutate the instance of a value class. But if you are outside, you should not do it. So the idea is when you call new on a value class, you will create an instance in a spatial state called larval object, which means it's not fully object. It's this object is currently mutable. And then after the constructor being called, the object become immutable. The nice thing with this is that it means that if you take a look to how to use a classical object or an instance of a value class, from the user point of view, it's exactly the same code. Currently, I don't know if you know, but these things, the fact that you have a larval object and that you freeze it at the end of the constructor, only works if the object doesn't escape. Because if the object is stored in a static field, by example, you will store a larval object not fully finished inside something which is accessible. So currently, if you have a value class, the compiler will reject any code that escape this from the constructor. So this is a code that will be rejected by the Valhalla Java compiler if the class is declared as a value class. Because here you are calling validate with the population, and validate is an instance method. So an instance method takes this as first parameter. So you are escaping this outside.
You mean that if someone extends the class?
Yes,
for instance,
it's a problem, but yeah, the compiler is far more strict, which is even if you cannot extend, even if the class is final, because you can, inside validate, you can store it in some static field, this kind of code are not allowed. So in Java 21, you have a warning for this kind of class. So if you want your class to be able to migrate to value class in the future, you should enable this warning. It's not enabled by default. And the compiler will say to you, it's just a warning. Warning, you will not be able to transform this class as a value class in the future, so because this is escaping the constructor.
So are you telling us that a constructor should never call an instance method?
Yes.
Who is doing that, really? Yes, no one is doing that.
Yeah, it's okay. So this is how it works at the bytecode level. I don't know if you read bytecode, but it. So basically, it's exactly the same sequence of instruction if you are calling calling a value class, or if you are calling a classical class, what we call an identity class. Which means that you can take your code that is already using the class and just put value in front of the of the keyword class, and it will still work because it works exactly the same as usual, which is in the bytecode you can see that we do a new population. So in the bytecode, when you call a constructor, you do basically two different things. The first one is to allocate the object in memory, and the second one is to initialize it by calling the constructor. In case of a value classes, when you will create a value classes, it will return an instance which is tagged as larval, and when you come back from the constructor, the larval object will be frozen, which means that at that point you will not be able to mutate the fields anymore. So this is great. It means that we can take something like Java-long integer and just put value in front of it, and then there is no boxing anymore, or no boxing cost anymore. Applause? Yeah, small. So it's not fully true.
So take back the applause.
Yes, take back the applause. It's not fully true because we had to change the semantics of a class. If you have a value class, because we in Java you have some operations that are either using the address of the object, and for a value class an instance have no address, or are using the value of the header of the object. So if you do equals on an instance of a value class, obviously we cannot compare the address because there is no address. So we call recursively equals on each field. We don't call dot equals. So we do a component check of all things. Which means that the definition is recursive, which means that if you have a linked list of value classes, equals will traverse the whole linked list. Oops.
Who is using a linked list anyways?
For system.identity hashcode, so identity hashcode returns the hashcode if you have not override the hashcode method, which is basically a random number generated by the VM the first time you ask for the identity hashcode. So if you call system.identity hashcode on an instance of a value class, basically what the VM will do is hash all the fields. So an instance of a value class behaves a little differently, but we are able to have exactly the same operation as before. Synchronize. Synchronize is a real issue because I don't know if you know how it's implemented, but we need bits inside the header of an object to implement synchronize. And because there is no header for an instance of a value class, it will just throw an illegal monitor state exception. Obviously, nobody do a synchronize on a parameter. Yes, you only do synchronize on objects that you are controlling. And there is no weak reference because there is no pointer, there is no address. So there is no weak reference. It throws a runtime exception named identity exception if you try to create a weak reference of an instance, on an instance of a value class. Just to remember, stop doing equals in object.equals.
Really?
Yes.
Oh, come on.
It's written. Ah!
What should I be using then? Oh yes, that's
even if you don't think in terms of value classes, because if you think in terms of value classes, doing an equals on fields mean comparing each field. So basically, you are doing the code of equals twice. Once inside the equals and another after the equals. But even if you don't have a value class, I don't know if you know, I don't know if you have done some perf bench on the cost of doing equals in a dot equals method, but it's quite catastrophic, in fact. You have several issues. One is that you are introducing an if, which means that the CPU branch predictor will not be your friend, because obviously the branch predictor has no way to know if it will be true or false. If this code was never true, the VM will remove the code, but if it's true later, the VM will have to de-optimize the previous code and recompile all your software. You can see this kind of hiccup sometimes when and it works with modern GC like Shenandoah and ZGC, because when you have the objects that are moving at the same time you are running the program, like all concurrent GC does, it means that the object can point to the old address because they are not updated anymore. So it means that this kind of code needs to be protected with a read barrier, which means that you are losing performance for no reason at all.
But if I use my IDE to generate equals and there is an equal in it, so I should remove it. This is what you're telling us.
Yes, and kill the guy that have generated the snippet of code for.
No, we can't do that.
Why?
Because he's a nice guy.
Yeah, but yeah, maybe. Maybe it's one of the guys that want to sell more CPU times.
Oh, isn't it a pattern matching, for instance, of?
Yeah, so if you want to write an equals, just write it using an instance of. You can benchmark it and you will see that it's faster. Stop using the one generated by your IDE. They are not great. Okay, so I've finished my parenthesis about...
May I advertise that not the next episode, but the following episode of the Jet Cafe will be exactly on that?
Yes.
If you know what the Jet Cafe is.
That's a good that's a good thing. Okay, let's do a demo.
Exactly. So we are going to show you the code that we use to run, actually, to do all the benchmarks that we are going to show you. Oh my God, I can't believe this. I really need to do something. Presentation mode. So, as Remi mentioned, there is currently no compiler that supports value types, and we're going to talk about what's the name again? User-defined primitive types? No, the name changed.
No, it's value classes.
Value classes and non-null default, blah blah blah. Value classes.
Yeah, value classes.
There is no support for the language in the IDE whatsoever. So if you want to play with it, the first thing you need to do is to go to this page, jdkjava.net, and download this Valhalla virtual machine, JVM distribution that you have here. So if you go there, you just download the correct architecture for you, and you will have exactly the configuration that we are going to show you now, which is used to run this benchmark. Then after that, you will be able to create value records just by adding this annotation, a value, in front of records. And if you click on here, this annotation is actually defined in one of the projects you created, which is called the Civilizer, available on GitHub. So you can go on GitHub and download it. And it will be the same for the other types of value type that we're going to talk about. And this Civilizer is what you need to run all this code. Okay.
So, yeah. Technically, you don't need it if you don't want to use an IDE.
Yeah.
I mean, if you write all your code in Vim,
Emacs?
Yes, you don't need it.
Who is using Emacs? Yes. Okay. So you do download the code and you use your IDE to do that. This is old stuff. I mean, we're old people, you know that. And now, along with this project, you need to properly configure the dependency with ASM and stuff, and also configure the plugin so that it will trigger, when you package your project, it will trigger the rewriting of the bytecode. Basically, when you compile this code, okay, for instance this class, it will just compile regular classes along with annotations. And the bytecode rewriter will load this bytecode and generate another version of this bytecode, taken into account the fact that this record is actually a value record. And the bytecode generated will be the bytecode of a value record that can be run in the VM that I just showed you, a Valhalla VM based on Java 20, and apply all the optimization that you just talked about. This is how it's going, and I'm going to show you how it's working. I'm looking for okay, where's the Maven stuff? It's here. So I'm going to first clean this, clean the bytecode, then I'm going to call package. That should be enough. So that's the version of the Valhalla we're using. It's based on the Java 20, and that's the 20-75 version. And I think it was built in November 2022 or something like that. Yeah. And so it begins with compiling everything. Then it just scan every, that's the GMH one. So this one is not very interesting. But that's the department, for instance. So you see that, or the region that is here, you see that the rewriter detected that it's a zero default class. That's a special type of value class. This data city here is an identity class. So identity classes are just regular classes, the classes we've been using for 30 years. Zero default is a special type of value class that can be null. We're going to talk more about that in a minute. And the value class is just a class that we've been talking to you about. So this bytecode rewriter takes the regular bytecode and transforms it according to the annotation to another bytecode understood by this Valhalla virtual machine. Okay, and that's basically all I want to show you there. The rest, if you download this project on my GitHub account, the rest is just JMH benches. So if you've never been using JMH before, JMH is a little technical to use. It's not super hard, but you still need to understand how it's working. And the only thing you need to know is that it's the only way you can actually reliably create benchmarks for in-memory computations on the Java virtual machine. Doing loops and system current times in millis or system.nanotimes just give you results that are absolutely not reliable, so it's not even worth trying to do that. If you want to bench things precisely, JMH is the tool you want to use. All right, I'm going to go back in the slides. That's all I need to show, right? Yeah. So the first series of benchmarks, we just take a record with a name on a population. The population is an integer. And the second bench is a city and a population. Population is itself a record wrapping an integer. So that's the example we just showed you. And we are not doing any kind of value class whatsoever. So we're just observing here the difference between basically a record wrapping an int and a record wrapping another record wrapping an int. So we are just adding one layer of indirection, so one layer of pointer chasing. And we compare that with this array of cities, and you can see that the price you pay for the summing of this population object in the first version where city just wrap an integer, the sum is 24 microseconds. This U here is for microseconds. So we have a bunch of cities and population, but it's always the same. So it's not really worth looking at that. If you want to use really object-oriented stuff that is having a zero population and an add method on this population object, and what you get back is this population, which is exactly what you would like to have some meaningful code. Well, you pay a price that is quite high, by a factor of somehow almost 3, right? So in microsecond, it's not that much, but it's still a factor of 3. So if you're really in performances for your in-memory computation, probably you don't want to pay that price. And for the cities, then it's kind of the same. Here you just have cities, and cities is wrapping a population that is wrapping an int. But now you're just accessing the int and you're summing the int. You still have a factor of, let's say, 50% performance hit. So this is what Valhalla is trying to solve. Now, if you change this population object to a value record, so something that is going to be inlined within the city, you can see that actually the two last benches align one on the other. That is, adding integers by accessing them through this population object becomes actually the same as creating an add method on this population object that is having the right model for your data. This model is actually free now, just because these objects are not created at runtime. Okay. But now it's not exactly all, because we still have references that can be null, and we need to fix that.
Yeah. So what we have shown is that we are able to solve the problem of putting value on stack, which means that we are able to solve optional or this kind of object by just declaring them.
All the dates, all the date and time API
yes,
can be
using value classes. But we have not solved the representation on the heap, the representation in memory. Why? Because we have null. And if you want to substitute a population to just an int, we have the problem with the value null. What to do if the value is null? That's one part of the issue. The other part of the issue is the concurrency issue we'll see perhaps a little later. How to solve it? Remove null. What is the best way to remove null? We think that introducing a bang just after the type is a good way to say null is not allowed.
For this particular type?
Yes, for this particular type. So this is currently the proposed syntax. We have tried several ones. This is a simpler one, and it seems that everybody is able to understand it. What it means is that if you have a field which is declared with a population bang and you try to store null in it, you will get a null pointer exception. Obviously, it will not compile, but if you try to set it by reflection, you will get a null pointer. So this population bang is for fields and array element, things that have a representation in memory. Now we have a question, which is, what is the value of population bang by default? It cannot be null. It means we need the default value. What should be the default value? So we are not C++, so you will not choose which one it is, because it's just madness for the VM to do this kind of things. So we have decided for you that it will be the value with all the fields initialized with zeros in it. So if you want to use a population bang, it means that the default value will be all the fields equals to 0. But it's an issue because it's breaking encapsulation. It means that you are able to create a value without using a constructor. That's bad. Breaking encapsulation is bad. Yeah? So you need to introduce a special constructor that we call the implicit constructor to say it's fine to create a default value. This is a constructor that you don't have to write because the VM can write it for you. And this is a way to basically say it's okay to create an object of this class with every field initialized to 0. So if you have a value class with an implicit constructor, then you can use the bang. If you have just a value class, you cannot use bang on it. Or if you have a string, you cannot use bang on it. So it's only valid for value class with an implicit constructor. So if I have declared my population as a value class with an implicit constructor, in that case, I can use population bang inside a record. I can use it to create an array. I can use it inside the angle bracket of a generics type. So now what we want is to bench this kind of value class. So it's a kind of a second level of value class. It's not only a value class, it's a value class with an implicit constructor. And then when we declare a city, we are declaring that the population is a population bang, which means that if the city is stored in memory, instead of storing a pointer to a population, we will store directly the int value. So if we are using a population bang, technically we have exactly on stack, we have exactly the same behavior as the value class by default, which means that on stack having a population or having a population bang is not having a population bang does not give you more power than just having a population on stack.
Now having the performance is such that if you declare population bang, you have the same performances than having an int in the city record, so which was not the case previously.
Yes, if you compare this one with this one, oops. Here, when you crawl all the city, you don't have to do the pointer chasing anymore. Which means that in that case, using a city declare with an int or a city declare with a population bang, you have exactly the same performance.
Which is great. Come on, Remi, don't be that guy.
So this is the layout if you are using a city with a population object, and this is the layout if you are using a population bang. Basically, the population pointer has disappeared, and this is now an int which is stored in memory. Here you can still see that you have pointer because your array of cities are still an array of cities, but if you declare the array as an array of city bang, then in that case you will have no pointer anymore, and everything is, let's say, inline inside the same array.
But that means that you need to have this default constructor, implicit constructor in a city record.
Yes,
right?
I need an implicit constructor
value record
in population and in city.
And in city.
So basically, if you want to use bang, you need an implicit constructor. You cannot use bang without an implicit constructor. And if we do that, we have even better performance than the basic things, which is this is the first benchmark, and now using a city bang, here we have even 2 times faster. Oh.
I think there's a mistake. There's a typo on the slide. We
Yes,
shouldn't have Citibanks in.
This one should not have Citibank in it.
Yeah, the first one. The first one should not have Citibank because it's just
it's
a recap of the
copy-paste
previous one.
of the previous one. But yeah, in that case, we can even have a better performance than currently in Java, because currently in Java you cannot declare an array of anything but pointers.
What could possibly go wrong with concurrency?
Concurrency, or oopsies. Technically, you can have an issue with bang. If I have a field which is a city bang, and I initialize it, and I have two threads that concurrently write inside the same value, I will be in trouble, in big trouble.
Is this what people call the tirability?
Yes, the main issue is that because it's a city bang, it's not a pointer. It's all the fields of a city, which means you have several fields, which means that the equals here, the equals here doesn't store only one value, but several values, which means that in the assembly code you have several moves, which means that you can be
interrupted.
Unscheduled in between the two moves. So if you write a code like this, which is here I have a city with 1, 1, and 2, 2, and here I read it. I reading it and checking if the population and the surface can be different. It will throw an assertion error, because how it works in memory is you will want to write 1 and 1 on 2 fields and 2 and 2 on 2 fields, which means that pointers are great for concurrency, because when you assign something, you just assign a pointer. But if you are using a city bang, you are not using a pointer anymore. You are using tuples of value, and you can have trouble in between. So there is a cheap solution to solve that issue, which is not use a bang. If you don't use a bang, it's a classical object. It will using pointers, and in terms of representation, it means that the city is just a pointer, and it will write the right one. Exactly, this is not how it works. By default, you will not have this behavior. We are thinking that this behavior is too dangerous to make it the default. So by default, if the CPU is not able to do all the write in one instruction, it will still be stored as a pointer. Basically, it means that currently CPUs are able to write 128 bits in one write. If your object is bigger than that, by default, we will use a pointer. The VM will use a pointer, because it's too dangerous. And if you want to have this kind of terrible things, you need another keyword named non-atomic, which means it's fine to have several read and several write. So it's up to the developer that create here the value record to decide if it's terrible or not. if you can have more than one read and more than one write or not. And the default is no. Currently, it's not fully implemented in the VM. You have another way to solve this, which is if you write Citibank and you put volatile in front of it, it will be always a pointer. Because we know that there is no operation for doing volatile write in CPUs. So now, what if we merge Valhalla and Humber? What if we have a sealed interface and we have several records, and all these records are value classes? For that, we will use this. Basically, I want to compare all my populated objects. So a populated object can be a city, a department, or a region. So I need to write a comparator of populated object, which is something that will first find the population object and then compare the int inside the population object. And I will use a switch, because now I know that if I have, let's say, data classes, I will use a switch for it. And you can see some trouble. So currently it's with identity value. There is no value class here. We are comparing what you do if you are using the OOP approach or if you are using a switch. You can see that the switch is a little behind. It should not be the case technically, but we know the issue, and it will be fixed. But if you use a value record, you can see that if you are using OOP with a value record, you are faster than using just a record, because you are not following pointers anymore. And if you are using a switch, you have something which is very weird, and we don't know exactly why, but you have a kind of a bimodal performancing, which is depending on the, let's say, the weather, it will be compiled faster or not. And we have taken a look to the assembly code, and I was not able to find exactly the problem, so I just send it to my preferred Oracle engineer, and not heard of him currently. So it means that currently switches are not optimized for value object. We need to do more work here.
And the same for a classical OOP, by the way.
Yes, yes, yes.
Should it be faster than a polymorphic call in the end?
Yes, we hope, but it's hard when you don't know exactly the issue. It's hard to characterize it. And what if instead of using value record, we are using value record with an implicit constructor? And it's awful. But that one we know why.
So that's so much
So
better.
what is the issue? The main issue is that we are writing comparators, and comparators are generics. And generics have no... they are erased at compile time, which means that the VM doesn't know that the comparator is a comparator of value classes, because at runtime, all the type argument, all the things inside the angle bracket has disappeared, which means that currently, if you are using value classes with a generic type, basically it's like using pointers, because the VM have lost the information that it could be a city bang or a department bang, and so on.
Could it be the reason why we didn't show the stream API with this value?
Yes. So currently, if you are using a list apart arrays.asList, which just wrap an array and will work, but array list or stream or so on, everything that's using a type parameter currently doesn't work with value records with an implicit.
When you say it doesn't work, it's not optimized.
Yeah. I mean, you get a result, but what you have is you have flattened everything in your array, and then when you call the comparator, you just box things, and they'll go. So it's awful, because here we are sorting things, which means that we are doing n log n comparison call, and for each comparator, you do a boxing of the two value. So you have a kind of the worst of both worlds. Because if you allocate with everything with a pointer, you can use pointer everywhere. But here we are using a flattened representation in memory, but not when we call the comparator. Which means that we need specialized generics. That's the next item on the list. We are currently working on it, but we will change the way generics are working at runtime, because we need the information that the type argument is a bang or not. And once it will be done, in 10 years, we will have noise. Perhaps not 10 years. We already have a prototype of it.
Maybe 20.
No, less. Let's say less.
Okay.
So in the future, we may want to add bang on other type, like string bang, meaning put require non-null inside the code. This is so there is a proposal for it, driven by a guy from Google, the guy that have created Guava. It's called gspecify.org, and it specifies a set of annotation with a very specific semantics. And if everybody is agreeing that this is the right semantics for Java, we will implement it directly in the compiler. So currently, the main issue with all the non-null annotations that exist everywhere is that they have a different semantics, which means that nobody agrees on the right semantics for these kind of things. And if there is no agreement, it will never be integrated in Java. Just take a look to gspecify.org and see if it's the right semantics or not. So existing class can be retrofitted easily. We can retrofit optional, local date time, and so on, Boolean, integer, double. I don't know if you know, but on a 32 bits VM, if you are using a field which is a double or long, you can have 2 reads or 2 write already, which means that for a double with a big D or the long with a big L, we will declare them as non-atomic, because this is how the primitive already works. Usually you don't care because you are using a 64-bit CPUs anyway, and even things like Raspberry Pi are 64 bits now. And yeah, we will implement specialized generics, which means that we will be able to have an array list of bong and have no pointers inside of it. How it will work? Basically, it means that the JIT will generate several versions of the code. Instead of specializing the class code or specializing the byte code. So specializing the source code is like C++, specializing the byte code is more like C# or Swift does. Here what we will do is specialize when you JIT the code, which means that instead of having, if you have a method which is parameterized, you will have several versions of the method, depending if you call it with a city or with a department, which means that every specialization will be tailored for a specific bang. And another thing we want to do, we are not fully sure about it, is to retrofit primitive type to act like value classes. Because one problem we have with the introduction of value classes is that now we have three kinds of thingy. We have primitive type, we have value classes, and we have identity classes. And what we want to do is to trick people to think that primitive types are value classes. How we want to do this? We want to be able to call equals to string and hash code on any primitive things, even primitive literals. It will not be easy because if you write 2 dot equals 3, currently the compiler see 2 dot and transform it to a double. Oops. So we will have to wrestle with the grammar. We want to allow array list of int. Array list of int being exactly the same thing as array list of integer bang. We want int to be a subtype of integer, meaning that if you have a method that returns an integer in a superclass, we want to be able to override it with a method that returns an int in the subclass. And we want the VM to do automatic conversion in between an array of int and an array of integer bang. Because if you take a look in memory, it's exactly the same representation. So for the VM, it will be 2 different types, but the VM will be able to say, oh, don't worry, it's the same type when you are using it. Okay, what you should keep of this presentation. The transformation in between identity class and so on is about what you are giving up and what you get by giving things up. If you have an identity class and you give up the address in memory...
So identity classes are the regular classes, right?
Yes, identity class is the one you are currently using. Identity class, and you say, I give up the address in memory. In that case, you have value classes, and what you get as a performance benefit is scalarization on stack, which means that every new on stack will disappear. No boxing anymore. If you give up the nullness and you add an implicit constructor, which means that if you are using whatever the name bang value classes, in that case, what you are getting is the flattening in memory of small classes. And if you declare that your value classes is non-atomic, so if you are giving up the atomicity of load and store, in that case, you will get the flattening of bigger object. The VM will never be able to flatten really, really big object because it makes no sense. It means that when you will load it on the stack and so on, you will spend so much time to load it compared to a pointer that big object will never be flattened. Whatever, even if you try to put a lot of keywords in front.
Could string be in this category of objects? Because the array of a string can be really big. Most of the time it's probably very
string
small.
itself cannot be, because of the Java definition, which is you have something called string interning. If you do quote quote things, you can do an equals equals in between quote quote things, and it works. And it's something which is really hard to retrofit as a value class. So string is a kind of spatial things. If we do these kind of things, you will never know it, which is basically it will be very specific and only for string. Okay. So no, but basically a string is an array of value, and an array is still an object in Java.
Yeah, it could be as big as you need.
Yeah.
Maybe we'll have
the main
limited size.
The main issue with string is that if you want to be able to flatten it, it means that you need two representations. One for small string and one for big string. Everywhere in your code.
That's the job of the VM, right?
Yes, several people, several very, very good people have tried, and currently the results are not that great. Mostly because you have to specialize everywhere in the code, in all the JIT, in the GC and so on, for this kind of thing. Hey, it's a small string, you don't do this, you do this instead, and so on. So technically it's possible to have good performance on it. I don't think someone was able to crack that. It does not mean it will be available in the future, but not in the soonish future of Valhalla.
Do we have time for questions? We have 3 minutes left. Maybe we have time for one question or two?
Yeah?
Any questions? When is an object too big?
It depends on your CPU, basically.
And it probably depends on the time frame you're living in.
Yes, exactly. So we know that small objects are currently 128 bits, because both on ARM and on Intel, you can have atomic write in that case. So small object is currently now 128 bits. We may be able to, if you say it's non-atomic, which means it's a middle-sized object, we may be able to go to 1024
that's 1K
bits. Yes.
Maybe there's another answer to that also. You see that when you are flattening your objects with the Citibank / population bank example, the last that we showed, actually the larger the object, the less interesting it becomes to sum all the population objects together, because your population objects are actually going to be spread apart in memory, and the benefit you have when you transfer
you mean the fields with it. If
Yeah.
you have a lot of fields and you do a loop on only some fields,
Yeah.
you will still have to load in your cache all the not in register you will be able to load only the fields you are using, but in the cache you will have to load the whole object.
Which is useless because you're only using one field, maybe among 4 fields or
Yeah.
something.
So I mean, Java will not change the physics of our CPU work.
Absolutely.
Sadly.
Will you have then a fixed choice of is it going to be 128 bits or is it going to be different on any machine which supports a wider? Because
So the question is this 128 bits dependent on the CPU? And the answer is a clear yes.
Yes.
And it depends on the CPU as of now, and the upcoming CPUs will be maybe the limit will be pushed to 256.
Java is kind of like wants to have a standard, right? So I can imagine that you would say no, we're going to have 128 bits.
So the question is, oh yes, but Java is a standard, so the limit should be put to 128 bits. Yes, but Java was designed like 30 years ago, when most of the machine was 32 bits. Some of them was 16 bits, even 8 bits. And now we have 64 bits with 128 bits buses to transfer the data, and Java is still working on it.
I mean,
so that's fine. Yeah.
Java, if you run in 2 different CPUs, actually, Java doesn't generate the same assembly code. Even if it's 2 Intel processor, because Java will sniff the actual if you have some vectorized operation and things like this, and use them. So already currently in terms of, a good example is the crypto things. Basically, if you have the operation to do crypto fast, Java will use that. If you don't have it, it will use the slow method. It's already happening. This kind of things already happening. So yes, people will not paper all their code with value classes. But maybe if you are writing a data structure, even if you are writing things like that move data in memory, you will use value classes when it makes sense.
Does that mean that in case we decide to run our code in the future on GPUs, this atomic part will widen, for example, to 124 bits or 1024 bits or even wider? Because today's GPUs, they have 4,000 bits wide memory paths.
You want to summarize? I would say, what about GPUs?
Yeah, what about GPUs?
And yeah, so for GPUs, currently you cannot run bytecodes on GPUs. There is a nice OpenJDK project named Babylon that is starting now, which is how to transform Java code and not bytecode. Java code to be able to target GPUs. But GPUs are quite different. You cannot do concurrency, by example, on GPU and so on. So it will depend exactly how Babylon works on this kind of thing.
Wasn't there another project?
Yes,
a long time ago for GPUs that was dropped.
Yeah, but it was specific to. So there was 2 different projects, one on NVIDIA GPUs and another on.
Can't remember the name.
So ATI or EMD things, but they were so specific to a GPU that the project were abandoned.
Basically, they failed because they had this
Not exactly. It was. Yeah, but it's more complex than that. It's basically the way to talk to one GPU is not exactly the same as the way to, and because those two projects were done directly by NVIDIA and by AMD, they only focus on their use case and not the use cases of everybody.
I think we are done. We are almost over time, by the way. So thank you, everybody, for your attention, and have a great rest of the conference. And don't forget to vote. Sorry, there's an app. You can vote. You can provide feedback, and we read the feedback. So if you have any feedback, by all means, please use the app. Thank you.